All right, everyone. So today we're going to be talking about 6.1, which is going to discuss operations on functions. So the key concepts and main ideas here are we're going to be adding, subtracting, multiplying, and dividing functions. So it's important that you know what it looks like when they're asking you to do these different things. They may say f plus g, or they may say it as f plus g and then parenthesis x. So what that means is you're adding the functions together. So like f of x plus g of x, these two functions added together. Okay. And just like before, with addition, subtraction is similar. You're going to subtract the two functions. And of course, pay special attention to the order here, because order does matter with subtraction. And of course, when you plug the expressions in for these functions, make sure that you're distributing that negative sign. Okay, that does affect things. And then multiplying two functions, when you multiply two functions together, so if they are larger functions, like one's a trinomial, one's a binomial, you might want to use the area model or the box method to do that. And then we have division, where you're dividing two functions. And just like with subtraction, be careful about order because the order matters. And then lastly, we have evaluating functions. This is when you plug a value into a function. That could be several different things. That could be like a single number, like f of 2. You're going to plug 2 in for each x value in the function. It could be like also where you take a function and you plug in 2x into the function. Okay, evaluating means that you're plugging a value into that function and then evaluating it for each variable that there is in the function. So, domain restrictions occur when adding, subtracting, and multiplying and dividing functions. The domain consists of the x values that are common in both functions, f and g. And when dividing, the domain will exclude any x value for which g of x is equal to 0. And the reason that excludes that in the domain, specifically when we're doing division, is because the g of x is the one that's in the denominator. And if you're in the denominator, you can't be 0. So that's why you have to be careful about looking for these domain restrictions. I always say just be careful if you have a denominator to make sure that you find all the values for which make that denominator 0. Okay, so let's go ahead and try adding and subtracting these functions. First and foremost, let's go ahead and identify each individual domain for the f of x and the g of x. So if I look at my f of x function, the domain for the f of x function is pretty straightforward, okay? In this case, it's just a quadratic, and we know that quadratic functions have a domain of all real numbers because there are no restrictions on that domain. Restrictions on a domain usually occur when we have a square root or a type of root, and when we have a denominator and things like that. And then the next one is just a linear function. And we know that the domain of a linear function is all real numbers, so negative infinity to positive infinity. And there's no restrictions on the domain of a linear function unless there's restrictions put in place. So if we add f of x and g of x together, let's go ahead and do that. So that's the same thing as doing f of x plus g of x. So once you set that up, you're just going to add these two together. So x squared plus 5x minus 2 plus, and then I'll put the other one in another color. Let's do, it's like the same as red, but okay, whatever. 3x minus 2. And then once we have that, we can now combine like terms. So we have a few different like terms here. This is a little big, but you get the idea. We're going to go ahead and add those like terms, combine like terms. So the x squared is going to stay as is because there are no like terms with it. And then we're going to add the 5x and the 3x, which is 8x. And then -2 minus 2 is -4. So that is f of x plus g of x. And then we want to know the domain. Well, the domain is still all real numbers, okay? It's still a quadratic function. Nothing has changed in a way that causes the domain to change. And as we can see here, when adding, subtracting, or multiplying, we're in this case adding. The domain consists of values that are in common of both domains. As you can see, since they're both real numbers already, the domain of the sum is also going to be all real numbers. Now we're going to evaluate f of x plus g of x of -1. That means we're going to be plugging -1 in for x. So we're going to take the function that we just came up with, and we're going to plug -1 into that function. So when we square -1, it becomes 1. That becomes -8, and that becomes -4. That's equal to 1 minus 8 is -7, minus 4 is -11. So when you evaluate and you're plugging in a number, you're going to get a number as an answer. Now, that's not to say you can't get something with a variable if what you plug in is a variable. So yeah, that's the answer to that question. Let's move on to the other part. So if we move on to part B, we're going to be subtracting these functions. So I'm going to write f of x out. And we're subtracting away g of x. So notice that I put the parentheses there. That's really important when we're doing subtraction because we need to distribute that negative sign onto all the terms. So that's x squared plus 5x minus 2 minus 3x plus 2. And now once again we're going to combine like terms. That's x squared plus 2x, and then these cancel each other out. -2 plus 2 is just 0, and the domain is still all real numbers. And now we're going to evaluate f of x minus g of x of 2. All right, so now we're going to talk about transformations of functions. So if we have a function, a parent function, in this case, y equals the square root of x, we can shift that function or stretch it or compress it. We can do different things that affect the function, and we're going to talk about that now. So the first type of transformation you have is a vertical shift upward. So how that affects the function is it basically shifts all of the y values up k units. I'm not sure why this looks so blurry. Let me try another screenshot. There we go. Okay, it was kind of blurry for some reason. So it's going to shift every single y value up k units. So vertically shifts y values k units up. Okay. So what that means is whatever k is, it's some number. In this case, we're going to make our k value 1. We're going to shift